Well, hello there. Good to see you again. This is recording 1A for Rational Expressions, Unit 6, Chapter 6 of Mathematics 2200. We're going to focus here on defining a rational expression and on non-permissible values. So what is a rational expression? Well, simply put, it is the quotient of two polynomials. A polynomial divided by a polynomial. So for example, x squared minus 6x plus 8, that's a quadratic polynomial, divided by x minus 4, which is a linear polynomial. X squared minus 4x, that is also a rational expression because we could write it over the monomial 1 if we chose. So it would have denominator 1. It could be a monomial divided by a monomial. It could be a trinomial divided by a trinomial. A monomial divided by a binomial, or any combination of a polynomial divided by a polynomial. They're also known, rational expressions are also known as algebraic fractions. Now, many rational expressions have what is known as a non-permissible value. So for example, if we take x squared minus 6x plus 8 divided by x minus 4, and we substitute the value x equals 4 in place of x. We get 4 squared minus 6 times 4 plus 8 over 4 minus 4, 16 minus 24 plus 8 over 0. And the one number in the world we're not allowed to divide by is 0. So even though we get a 0 in the top as well, we have division by 0. How many zeros would it take to make 0? That's what this division statement is saying. So you keep adding up zeros and see how many you would use. Division by 0, undefined. That means that x equals 4, that is a non-permissible value. I'll abbreviate that as NPV. And the next one, I'm told to try two possible values. So if I put in the 0, I've got 1 over 0 squared minus 4 times 0, which is 1 over 0. Well, how many zeros would it take to make 1? That's undefined. You'll never add up enough zeros to get to 1. And let's try putting in 4 for the x. We have 4 squared minus 4 times 4, which is 1 over 16 minus 16. We get 1 over 0 again. So again, division by 0 is undefined, and both x equals 0 and x equals 4 are non-permissible values. For this third one, I've again got two possible values to try. Let's see what happens. In the case of putting in p equals 4, I get 0 over 0. That's undefined. You can satisfy yourself on that calculation. And when the value of p is 6, substituting that in, I get 70 over 0. So both of these are undefined. And therefore, both p equals 4 and p equals 6 are non-permissible values. So non-permissible values are values of the variable that would result in division by 0 through the roots of the denominator. And if x equals a is a non-permissible value, then we say the restriction on the variable is x cannot be equal to a. So for example, in our first one, the non-permissible value is x equals 4, but we would say the restriction is x not equal to 4. So let's see how we might find those non-permissible values. First, if I have a rational expression, the first thing I do is take the denominator and set it equal to 0. So in this case, I have x squared minus 4x, make that equal to 0. And I solve the resulting equation for the roots. So in this case, it's quadratic, and I can solve this by factoring, take out a common factor of x. Make each factor equal to 0. Well, the first one is x equals 0. And the second one, x minus 4 equals 0, so x equals 4. Those are my two non-permissible values, and therefore we can say the restrictions on the variable are x cannot be 0 or 4. On to example 2. We have x minus 2 over x squared minus 4x plus 4. Again, we set the denominator equal to 0. So x squared minus 4x plus 4 equals 0. Solve that resulting equation. Again, I can factor this. I don't need to use a quadratic formula. It factors as x minus 2 equals 0. It's a perfect square trinomial. So we only need to make that one factor equal 0 because it's the same factor twice. And therefore, x equals 2 is our non-permissible value. So if that's our non-permissible value, we can say the restriction on the variable is x cannot be 2. In other words, we shouldn't substitute x equals 2 into this expression. In conclusion, a rational expression is the quotient of two polynomials. Non-permissible values are values of the variable that would result in division by 0. They are, in other words, the roots of the denominator. And to find the non-permissible values for a rational expression, set the denominator equal to 0 and solve the resulting equation for the roots.